This is lesson 1.3, Other Sampling Methods. The goal today is to be able to understand and evaluate random processes underlying statistical experiments. In lesson 1.2, we discussed a common sampling method called simple random sampling. So we used a random number table. You could also use a random number generator, a variety of ways that we use to collect a simple random sample of a population. There are 3 other common sampling methods, including we will talk about systematic, random sampling. We'll talk today about cluster sampling, and finally we'll talk about stratified sampling. So first of all, we have systematic random sampling. So first of all, a little bit about this method. We sample members from a larger population that are selected according to a random starting point. And a fixed periodic interval. This interval is called the sampling interval, and it's calculated by dividing the population size by the desired sample size. So that's kind of a lot of information here. We have several new terms. We have systematic random sampling, probably a new term for you. We have random starting point. We also have a new term, periodic interval. And then we have this method for acquiring the sampling, we have a method for calculating the periodic interval. So this is how to calculate the periodic interval. Now, to go along with that, we love to associate a variable with different phrases like these that make it simpler to incorporate into our equations. And so the random starting point, we're going to use the lowercase letter k for starting point. And for the periodic interval, we'll use the lowercase letter m. So taking a look at this image here, we have systematic sampling among this group of 20 individuals. And you can see that prior to these lines drawn and these circles, this was just a plain group of 20 people lined up. And you can see by the way that these marks are drawn that we have a periodic interval of size 4. So that means in this situation here, m equals 4. And we have a random starting point then within this interval where between 1 and 4 a random number was chosen. So that would be 3. And then to get to the next spot, we add that 4 on each time. And we'll talk more about that process down below. So you can see then that the random starting point, k, is 3. Now how did we get 4? Well, it was known, it was decided ahead of time that there was a desired sample size of 5. 1, 2, 3, 4, 5. So you see that the 5 are already circled. So we had an initial sample size, a given sample size was 5. And then to find M, right, M is found using this method, right? This is M, the process for finding M, by taking the total population size, you can see, so we'll write that down as well, is 20. And we know to get M, we simply do the population size, 20, divided by the sample size, 5, which gives us that 4. I'll walk through that again one more time. Again, it can get tricky when you have all of this new vocabulary and a new process. So just be patient with yourself as you work through this and practice problems in your upcoming assignment. So we have systematic random sampling. Systematic, there's this system in place that involves a starting point and a periodic interval. So we have we sample members from a larger population. In this case, we have 20. And they are selected according to a random starting point, K, and a fixed periodic interval, M. So again, how do we pick this random starting point? We could choose a number from a random number table where the number has to be between 1 and whatever that M value is. We could also use a random number generator. So I downloaded a quick random number generator, so I could say between 1 and 4, I want to generate a random number. So I do that here. So you see this time it pulled up 2. So 2 would be just as good of a random starting point, but in this case it's 3. So then this interval, called the sampling interval, again, is calculated by dividing the population size by the desired sample size. So let's look at this process. This is a step-by-step process. I like a step-by-step process. We go boom, 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 and we can go back and reference this above. This is more of kind of an overview of the systematic sampling and with an example. How to generate a systematic random sample. Okay, so first divide a population size by the sample size, and then we always round down to the nearest whole number, M. Okay, so rounding down is sort of an odd thing to do when we're used to just rounding up if it's 5 or higher, rounding down if it's 4 or under. So in this case, you always round down. Use a random number generator to obtain a number K between 1 and M. So once you have that M value, like we had above, M was 4, randomly we selected a number that was 3 for K. Again, that had to be between 1 and 4. And then we select for the sample those members of the population that are numbered K. So remember K was 3. And then K plus M, so 3 plus 4, which is 7. And then K plus 2M, so 3 plus 2 times 4, or 3 plus 8, which would be 3 plus 8. So that would get us to 11. And then K plus 3M, so that would be 3 plus 4 times 3. So that would be 15. And then finally, you would keep going, dot, 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 until you hit the end of your population size. Let's look at another example. Monroe High School has 1,027 students, grades 7 through 12. They desire to have classes of 15 students each. First, identify the population and the sample. So the population here would be all Monroe High School students. And the sample would be the 15 students in the class. Now we're going to follow these steps, A to C, one at a time, to generate a list of numbers representing one class. So we have to start, step one, divide the population size, 1,027, and we have to divide that by the sample size, 15, and we get 68. Next, we need to choose a random number between 1 and k. Right, this is k, or sorry, this is m. A random number between 1 and m. So with m being 68, a random number between 1 and 68, so you randomly look, I get my random number generator and I come up with 49. Finally, I apply this process. So the first student that I choose between, amongst all of these 1,027 students would be student number 49, right? That's our K value here. So we would start with student number 49. Next, we would look at K plus M to get into that second interval. So we would do 49 plus 68. So we have 117. Now you could just continue to add on to that another 68 each time to get into that. See, each time we could just say, oh, and plus 4, and plus 4, and plus 4. Or algebraically, simplest way to express it would be this way. So we could say, okay, then what's K plus 2M? So what's 49 plus 2 times 68? And that's 185. And then we have K plus 3 times 68. And so we get 253. And we continue on with this process, 49 plus 4 times 68, 49 plus 5 times 68, 49 plus 6 times 68, all the way until we complete our sample size, which again, going back to the problem, is 15, and we identified that here, 15 students. So you can just simply use your calculator and write those numbers out. So we do 49 plus 4 times 68, and that gives us 321. Now let's see, we're at student number 1, 2, 3, 4, 5. So we need 10 more numbers. And then the next one would be 389. And then 457. And 525. 593. So we need 4 more. So you can see, if I were to add another 68 onto, 68 onto 1001, I would actually surpass my population size. So that's another indicator that you've gone far enough. If you were to add on one more round of your M value, you would be out of the range. And we do have now 15 students. So student numbered 185, and so on would make up that first class if we used this sampling method.